Today's lesson is about ionization energy. First of all, let's get to know about what is known as ionization energy. The ionization energy means the minimum amount of energy that is required to remove an electron from an isolated gaseous atom or a molecule. So, what is known as an ion? An ion is any atom or a molecule in which the number of protons are not equal to the number of electrons. So, it is a charged atom or a molecule. When the proton number is not equal to the electron number, it is a charged atom or a molecule. Let's see a few examples. If we take hydrogen, normally hydrogen is a neutral. So, let's see how the hydrogen ionization happens. If you write like this, the hydrogen wants to remove one electron. Hydrogen has one proton and one electron. Now when we write hydrogen plus one electron, that means now the hydrogen has only one proton in its nucleus and the electron was given away. Now it is known as the ionization. So because the minus charge went away, now the charge of the proton is positive and hydrogen is considered as positively charged. This is called a special, very beautiful name for this. Now this H plus 1 is known as the cation. This H plus is known as the cation. If we take chlorine, the chlorine has 7 valence electrons, and if we write like this and add 1 electron for it, it becomes the stable state, that means 8 electrons. So because of adding an electron, it becomes minusly charged or negatively charged. Now it has a special name, it is known as anion. The negatively charged ion is known as the anion. So the positively charged ion is known as a cation and the negatively charged ion is known as the anion. So let's discuss this ionization energy with regards to the periodic table. By that it will help us to know which elements will be harder to remove electrons from it and which ones will be easier. Let's start with group 1. The group 1 includes alkaline metals. In order to achieve the magic number 8, the stable configuration in the outermost shell, the easiest way for them is to get rid of one valence electron they have in their outermost shell. Let's consider about potassium first. Potassium has one valence electron in its fourth shell. If it removes that electron, then it can get to the noble gas electronic configuration of argon. So these guys really wants to give away electrons. So it requires very little energy to ionize them. So this is low ionization energy. In this side it is low ionization energy. What about neon? Neon is completely satisfied and it doesn't want to even deal with any reaction business. So it really doesn't want to give away its electrons. Neon, argon, krypton, xenon or any of these noble gases, they don't want to give away their electrons. So if to remove an electron from these, it requires a large amount of energy. So in this side, it is high ionization energy. So generally, let's see what is the trend. When you go from left to right across the periodic table, it goes from low energy to high energy. The ionization energy increases from left to right. It is easy to remember that the elements in group 1 and 2 are ready to get rid of their electrons in the shell, but the elements in group 7, 8 likewise, they never wants to remove their electrons. Fluorine is also same. As they tend to get an electron rather than removing their electron, their ionization energy is very high, and they trying to achieve the noble gas configuration by achieving an electron. Now let's see what is happening down the globe. As usually, let's consider about alkaline metals, as they are ready to give away electrons. But when you go down, the electrons cloud get bigger and bigger. If we consider about cesium and lithium, the neutral cesium atom, it has 55 electrons. The 55th electron in its outermost shell is further away from the nucleus of this atom than the third electron of lithium. So the 55th electron of cesium has weaker attraction or a less attraction to the nucleus rather than the third electron of the lithium. So this cesium wants to give away its electron, or it tends to give its electron away even more than the lithium does. That means cesium gives their outermost electron more easier than the lithium. So the ionization energy decreases as it goes from downwards to a groove. So in generally, let's see what is the trend. In generally, the ionization energy along a groove will increase as they go up. The bottom is low ionization energy. The top of the groove, it is high ionization energy. These things don't need to memorize because it may be useful for one or two of your tests, but in the later part of your higher studies, you need to keep it in your inner memory. So don't need to get it memorized, you just get the fact of this. If we consider about cesium and fluorine, what is easy to remove? It is easy to say that by just looking at the periodic table if we know the basics. So let's see. Cesium has the outermost shell, the 55th shell is close to super far away from the nucleus. The cesium's outermost shell is super far away from the nucleus. But the fluorine has 9 electrons and it is more tends to get 1 electron rather than giving a electron. So it is difficult to remove an electron from fluorine rather than cesium. So it is clear that the energy that is needed to remove an electron from cesium is low than the energy that is needed to remove an electron from the fluorine. So finally we can tell that a very low energy needed for cesium and a very high energy at fluorine. So you can easily see the trend of how the energy varies in the ionization energy. So this is a graph which is drawn with the actually measured energies of the ionization. This was drawn with the atomic number, you can see. So let's say about hydrogen, it is the first atom. The energy that needed for it is around 13.5 electron volts. Electron volts is a measuring unit. So after that, when you go for helium, it is almost the double of energy. It is around 25 electron volts. Then when you are going further and further, you can see the lithium. It is suddenly a huge drop of the energy because the first group elements, alkaline elements, so alkaline metals, in here you can see that lithium needed almost very low energy when you are considered with the hydrogen. It is around 5 electron volts. And when you are going further, you can see that the energy increases towards the neon. When you are going from left to right, it shows the electrons are not easy to remove. That means the energy, the ionization energies increases while the group from left to right. Again, after neon, it is sudden drop for the sodium. Sodium, the energy needed is less than the lithium. So down the group, the ionization energy is decreasing. Again, it is increasing from left to right, and argon, it is stable but not as higher energy like neon, because it is going down the group. I think that you can remember that, we now see that the pattern, there is a regular pattern of this from left to right. It increases the ionization energy, and from top to bottom, the ionization energy is decreasing. When you think about the noble gases, helium, neon, argon, krypton, xenon, you can see that rather than the elements like lithium, sodium, those noble gas elements, they need higher amount of energies. But if you think, there is also decrease in the amount of energy when you are going from top to bottom. When you start from helium, it is the highest energy. If you think about neon, argon, the energy is decreasing step by step. So let's see what are the general trends in here. When you're going from left to right along the periodic table, you can see the ionization energy that is required is increasing from left to right along the periodic table. When we consider about top to bottom along a group, the ionization energy decreases. The ionization energy decreases. That is basically because the radius, the atomic radius increases. By that, the bond between the outermost electron with the nucleus reducing, and because of that, it is easy to remove the electron, so it needs a lesser amount of energy. So from top to bottom, the ionization energy decreases along a group. So these are the things that you should know basically about the ionization energy.